right, welcome back, Internet, to another episode of Makers on Tap, the podcast for makerspace people. None of us are directors. Drink and talk about making stuff.
You can tell it's been a little bit since Joe's hosted.
It has been, boy. All right. So I'm your host tonight, Joe, and with me are...
Aaron.
Chris.
Matt.
And Luke. All
right. That is always so fun and awkward to watch people like, is it my turn yet? It's also funny when we're playing the intro music, since we can all hear it now on our new platform. It's fun to watch everybody's different dance.
Yeah, I was like thinking, do I, where am I?
Oh yeah, no, I get into it. I'm all Night at the Roxbury in here.
Great movie.
All right. So Luke, Matt, who are you guys? Why are you here? What are you doing?
Yeah,
what are you drinking?
Yeah, what are you drinking?
We'll start with that.
We haven't done a what are you drinking in a while.
So I'm drinking Summer Teeth by Columbus Brewing Company, or CBC here.
Oh,
so
nice.
I think I've had Summer Teeth before. The Bodhi IPA is what everybody drinks, but I was just wanting something lighter. So it's pretty good. So got to represent.
Yeah.
Hell yeah.
For sure. Luke, what are you drinking?
If you have a chance to get the Bodhi, you should get the Bodhi. That's a delicious beer.
Bodhi's
Get the
good.
Bodhi.
All right.
I actually have a homebrew that I brewed with one of my buddies. It's called Pliny the Warrior. It's a triple IPA. We call it a trippa. You drink it. 10%. And it's got a lot of hops in it. We actually used a concentrated hop extract to make it. So it's pretty interesting.
I dig it.
I'm into it. Is it like a Pliny the Elder? Like. Wow.
That super dark, hazy, very heavy, thick, but it's got a creaminess to it because it's hazy and not clear. So it's not really like Pliny the Elder or Pliny the Younger, but it's a knockoff of Pliny the Younger with warrior hops. So hence Pliny the Warrior.
Nice. One of the guys in our makerspace that brews does a Pliny the Elder clone often.
Ooh,
and
nice.
He's given me a couple of growlers of it, and it's pretty great. So
I want one.
Tonight I'm going with one of my old standbys, Voodoo Ranger IPA.
Heck yeah.
I have stuff to do after the podcast, so I didn't really want to hammer it down.
Fair enough.
And I just got some Blue Moon, the mango wheat.
There you go.
And you guys are actually drinking alcohol, and I'm just over here with my Baja Blast.
I heard they're going to cancel Baja Blast.
I did, which is why I'm addicted to it again before it goes.
Awesome. Aaron, I see you still have the remnants of our CR30 build in the background.
Yeah. I mean, it actually works. I don't know.
No, I'm talking about all the beers we drank while.
Oh, yeah. Yes, there are several cans of empty dank meme behind me.
For the record, we built that together. We're all vaccinated now, so we could do stuff. The CDC says we can. It's fine.
And we were still safe and whatnot. Like we were definitely not like coughing all over each other and whatnot. But yeah, we got together for Aaron's birthday and got to actually build a 30, and hopefully in the future we might do a video around some of the stuff that we found with it during building that one while we build mine.
We started a fight on the internet and showed everybody wiring scariness, and that was the most active Twitter thing that I've ever started. That was fun.
Yeah, surprised how much traction that got.
I was too. I was surprised at how much argument there was over whether or not it's okay to put tinned wires in a screw terminal. If you're wondering, it's not. It's not okay.
Really?
There's
I didn't know that.
Loads of engineering papers on why it's not, and studies on why it's a fire hazard, and so you can argue with me all you want about how tinned wires are okay, but they're not.
Yeah.
I could see it. Little things like that. I could see starting a battle like that. That makes sense. We argue about that stuff all the time. Well, you can't do with wires. It's like all the time. Luke's always right.
Yeah. I have never seen a paper saying you should 10 wires in a screw terminal. I've seen lots of white papers on why you shouldn't 10 wires in screw terminals, and like
after you say that out loud, it makes a lot of sense because you're like that small point of contact where the tin touches the top of the screw terminal isn't really going to cut it.
right.
Mm-hmm.
Yeah, it makes a lot of sense once you said it out loud, but I've never actually thought about it.
Yeah.
It's one of those things where like there is applications where it is acceptable and it's like, okay, maybe in this circumstance it's not as bad. We actually, like me and Joe were talking that night of like audio work. That's a very common practice in audio work for you to 10 your wires for you to go into some terminals. But like you're also not carrying a whole bunch of load on those wires, so it's not as much of a risk. It's still not good practice, but it's not as much of a risk. And that's why
also,
it really
a lot of those terminals are round. So they're they're made to accept a round wire versus screw terminals are usually square. And they're made to accept either a bare wire that will be crushed in the terminal or a square crimped ferrule. And like when you get that round kind of like semi-crystalline metal in there that softens over time and crushes, then you get flutter in the contact, and then you get arcing, and then you get fires, and it's fun.
Yeah, it's a recipe for disaster that's been known for quite a while, that the inactiveness towards fixing it is really irritating, to be honest.
Yeah. But, all that's covered on Twitter if you follow us. Even why they do it. That was addressed by Naomi. So that, it was a good thing. Anyway, we are here with Matt and Luke for reasons. Who are you guys? Why are you here?
Yeah, so we're with IC3D. You might be familiar with IC3D from filament, but we do a handful of other things. Filament's one part of what we do, but we also have a 3D printing service, and we also now manufacture 3D printers. We have a consulting wing where we have a research grant with the Army, so that we have an SBIR with the Army.
Oh wow, that is not easy to get
to develop a specific filament. So we actually are very vertically integrated as a company. Just we have kind of a lot of different things that we do, and we're pretty spread out. So, but a lot of people are familiar with us because of the filament that we make. It's one thing that we do. So, and I am, my title would be COO. So Chief Operating Officer. It used to be when we were really small was VP of everything else. So it's just like everything else was kind of my thing. But Luke is our extrusion engineer. So Luke makes filament. Luke is now spending a lot more of his time developing new materials, working on the SBIR, and helping to build a lot of the equipment or modify a lot of the equipment to make upgrades to what we do, which is something that I think you'll find a lot of
awesome
shops, like us are constantly kind of building a lot of our own stuff. So.
Do you guys still run the open filament standard where your filament extrusion line is all open source and everything?
It is.
I was just going to ask about that.
Yeah, it is still open. We have not changed. We've not changed that about the materials that we've released as open and got certified as open. We probably aren't as on top of it as we should be as far as updating our documentation. And then the new materials we're releasing, that aren't open, it's mainly just because of timing and just the effort getting the documentation ready. And we just haven't gotten there yet.
Oh, so for sure.
I think there will be more of the materials that are open. And we've been kind of a little slow on releasing materials in our printing service. We've been using a lot of new materials for the last 12, 24 months or so. But we've got a lot that we're just trying to roll out a new one every month or every other month here soon. So you guys saw the Recycled PETG came out recently. We got a PCPBT coming out this month. We'll have a UV PETG coming out the next month. We just got a few more. So I can keep going, but I don't remember which month is what. So
high temperature ABS is in there, right?
We got a high temp ABS coming out. We got an ASA we've been working on for a while.
ASA, yeah.
But the UV PETG, I think, is going to be more popular than the ASA. That's just me. So
I would agree with you. From printing ASA, I agree with you.
Yeah. So we've been using that for over a year, like maybe a year and a half. And we've been really, it sounds kind of silly. We really haven't just been, we've been focused on other things, and we just haven't released it as a product, which is silly. So I guess maybe COVID kind of happened and really flipped. I hate to say the same thing everybody says, but it really did kind of change our plans. So
that brings up a really interesting thought, because we haven't really we've talked to people who made things during COVID, but we haven't talked to anybody who made filament during COVID. How did that change your core? Like,
that was fun.
So, okay. Before COVID, what was like your best selling filament?
I feel like ABS has always been the best selling filament, which is really strange.
Really?
Because the very first one we made was ABS. And so we only made ABS at one point. That was the first thing we did. And then I think we really hooked in with a kind of like a core group of ABS users who just bought our ABS. And a lot of the guys I know that
you made really good ABS
for like 6 years or something. Yeah. A lot of people really, really like it. And a lot of it's 3 mil ABS, which is now getting even scarcer. So that was our core. And I would say, because we do a lot of B2B filament sales, I would almost say, I could still say ABS might still be the bulk of what we make. Luke would know way more than I do. I don't know.
Actually, it's changed recently, which is interesting.
Okay.
I think it actually got surpassed by PLA in the most recent time, and PETG is definitely very close to ABS after that. So ABS is second right now. But I do agree, pre-COVID, ABS 3 millimeter black would be our number one best-selling filament of all time.
Interesting.
Yeah, I have some rolls of that on our shelf over there. Probably because of Lulzbot.
I think if you go on a unit basis, I think you'll see the PLA sells more units, but I think volume-wise, ABS is probably still on top. We move a lot of ABS.
Huh. Yeah. Okay. Yeah. So when COVID hit, what did that do? Or I guess when the PPE craze hit.
Specifically for filament, we started consuming a lot because we were printing face shields like everybody. And then we got hit with a couple different big orders. Makers for COVID was huge. I'm trying to remember who else we did. Was it Mid-South Makers? Am I getting confused with someone else? Make for COVID was huge. They bought a lot. At one point, we were shipping out like 2 or 3 pallets a week of material over to those guys. We switched. So, I mean, we're filament wise, we're maybe not as big of an operation as some of the bigger guys. We have 2 extrusion lines, but we were running 24 hours a day, which is really unusual for us. And I think we ran like 24/6, Luke. I don't remember.
24/5, yeah.
24/5. Okay. We ran 24/5, which was pretty wild. And then we had the guys who were running at night. We're also flipping the printers, or starting the printers over. As we got about 30 TAZ workhorses that we're making. Man, I think each machine was probably making 21, 24, 20, 21, 25, 26 face shield, brims a day. And so we were actually running out of internal filament because we were shipping so much of it out. So we were actually like playing around with just kind of using anything we could, which was really pretty weird. It's pretty unusual for us. And then running 24/7 was interesting. I mean, yeah, that was a new one for us. That might be common for other companies to do, but we don't normally do it.
Yeah. That's crazy.
We also brought on a lot of new staff during that time. We had to train 3 new guys to help us run 24 hours a day. We were doing a lot more respooling, so we're breaking down large 10 kilogram spools into 5 kilogram, mostly 5 kilogram spools, or 2.5 kilogram spools, excuse me.
Yeah, I remember being pretty worried about material shortages. So we were buying, I want to say maybe 10 to 15 times the amount of plastic we were like, I mean, you know, yeah, it probably maybe we had 10 times the amount of plastic kind of sitting in the back, ready to go, just kind of stacked up. And that was really pretty strange for us to, you know. So
we were making more filament in a week than we would make in a month. Easily.
Wow. Mm. So was stockpiling the plastic, was that validated? Did you end up
even stockpiling it? It was going out the door, man.
Yeah.
Seriously, it was just flying off the shelves. Like we were putting pallets out of massive amounts of spools like every few days. It was busy.
Yeah, I think for a short time it felt like we were stockpiling it, but it just it wasn't very long before it was all gone. So it didn't even matter. So
definitely justified. That's crazy.
Yeah. There was a pretty big shortage for clear PETG face shields, and that was definitely like everybody ran out of that immediately.
Yeah, we're still feeling the price change from that.
Mm-hmm. Do you feel like you have a lot of people who like found you during that kind of spurt up that are now staying with you because of the quality of your guys' filament now?
Yeah, it definitely went up, and it didn't maintain that level, but it definitely went up and is higher than it was before. The revenue for that is higher. We definitely sell more material than we did, and we had a lot of guys, at least for COVID, that were kind of saying like, "Oh, we got some of that stuff. It was great. We loved it." Especially the PETG. People really like the PETG. Honestly, I haven't benchmarked that many other PETGs, so I think like ours works really well. I like it, but people really like it, so they really like it. Yeah, I would agree. Definitely, people stuck with us after that.
No, it's awesome.
I think the other big thing that happened was a shift from smaller quantity units to larger quantity units. So we've just done a lot more sales of high quantity units. Like we're doing a lot more 10 kg spools, mega spools that we would have never done before. So we're just selling those a lot more regularly.
The mega spools are interesting because it's always like, how am I going to hold this? And can my extruder spin this?
Yeah,
it's a trick. I think anybody who does large format printing at some point struggles with it. And, I don't think there's been too many really good solutions so far. We actually just built a motorized spool holder. So we've been using it for a few weeks now. And teasing out the problems with it. And it's been going really well. So
is it tied back to the extruder output so that like they're kind of clocked together?
It's like it works like the pallet. It works like the mosaic pallet, where it just once it gets there's enough tension, it just triggers a little release of more material. So
nice.
It's pretty cool. We think we're going to release them for sale. That's kind of the plan. It was really just something we've been developing in house for our own use. So we think that's where it's headed. More just a tool so that other people can use the 10 kg spools. But we print on Taz. We use 10 kg spools on Taz's. We use 10 kg spools on our big machines. Use them on everything. Sometimes the five pounders or the 2.5s are a whole lot easier to use. Just kind of depends on what material.
Yeah, I've got a 5 kilogram spool from the COVID stuff that I haven't opened yet. And now that I've got this CR30, I'm like, I don't even know if I have anything that can hold that spool, let alone pull it. So I think, I bet you, with these belt printers just coming out, I think there's going to be an increase in need for something like a motorized spool holder for these larger spools, because these machines are designed to, print 24/7.
Yeah, no, I think you're right. And, for us, I think we've been kind of blessed to sometimes we just don't think about filament. We can just leave the spools on there and keep going.
Right.
When you're doing big prints, even with the 10 kgs, we still have prints where we're swapping 10 kg spools mid print. And that's that's still pretty painful. I wish we could go bigger, and I think the motorized spool holder might allow us to go bigger. And not that I really want everyone having to like lug around like 40-pound spools, but it would be helpful. So
one of the problems that I ran into running mega spools was actually the spool freewheeling and like releasing more filament and loosening the bundle up. And then that causes knots. And it's like, that was terrible. So I ended up like making a spring loaded wiper pad from the Taz and just like running tension on the rim of the mega spool. And
that's a good way. We've done that before too. Yep.
Yeah, we went through a period where we put paint brushes on all our spool holders, so the brush would be like Wheel of Fortune style, like
click, 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 click.
It's really hard to pull. So you're like, let's put bearings on it, and then you put bearings on it, and then it pulls way too fast. It
spins forever.
So we've been through every, all those iterations over years and years, and this is kind of, I think, the first time where I feel like it's going to be a lot more consistent. I agree. It's kind of a pain in the butt. And I've talked to other guys that own big machines, and kind of no one really seems to have a good solution. And they're like really relieved, like, oh, it sucks for you too. You're like, yeah.
Yeah.
That's always validating.
So one of the things that my friend Adam and I have talked about a few times that we want really bad is a pallet that just has two outputs or two inputs that just purely is for spool swapping when running big prints. And like we've talked about some solutions with like the tool changer using sister tools and a filament runout sensor, because you can like start a print with the tool changer with like tool 0 and pause it, put tool 0 away, call tool 1 and like start the print again, and it'll work.
Yeah.
So you can script that and make that happen. But I'd also just really like a $200 pallet that just works and only has two inputs to splice spools.
Yeah.
That.
It's true that the pallet does that, the pallet does exactly that.
Yeah. But I don't want to spend $700 for it because I don't do multicolor prints very often. Yeah. I just want big prints. Big.
Yeah, I get what you're saying. I think that makes sense. Yeah, I think that's we basically have one side of the pallet right now. So the splicing, though, I don't know. That seems like a lot, but it would really help us to not have to swap out spools. So
yes,
we still run into that issue. So.
All right. So you mentioned the recycled PETG. You guys are doing a couple things for Earth Day, I think is what Claudio told me.
Yeah, for Earth Day, we're doing the first, at least I've seen, spool return. Just an official spool return. I guess the main goal is kind of for us, I think, is to tease out how realistic it is and, see where the problems are. There's a huge issue with spool return, right? It's not doesn't financially make any sense to ship spools.
Right.
So, we know that. And we have a couple customers that are big printing customers, and they do ship them back. And if we get a pallet of 200 to 300 spools back, it actually is cheaper to get those returned to us than it is to just buy new spools. It does make financial sense at some point.
Okay.
And so I think with this one, we have a Discord channel with all of our printer elves, and we're trying to get anyone interested to join that, and just kind of hoping that everyone can kind of work together as a team to find out some good ways of getting spools back to us. People are local. It won't be a big deal. But hopefully there's some clusters of guys, especially if they're printing elves, or maybe the make for COVID. If there's some way that guys can work together to get that to us, that's kind of what we're hoping that'll work out. So we're trialing that. We're trialing another thing that I don't think we've made really obvious, but it is in there, that we are going to accept inland spools. So we are accepting the Micro Center brand inland spools. And I would like to be able to release our recycled PETG on recycled spools. So there will be a little bit of a trick there. I don't want people to think that we are buying material from inland or from China or anything like that. I want people to know they're recycled. But those guys have a big store near us, and they have they sell quite a lot of material, and there's going to be a lot of those spools floating around and potentially going in the trash can. So I think that would be a really easy to recover spool that we could reuse again. But yeah, again, we need to find a way to make sure that everyone realizes that we are recycling those spools. But that was something that I wanted to try was we can't just, so at least for now in this controlled experiment, we don't want to say, everyone bring us any spool that you have. That would be really bad, right? But I don't know if necessarily if I want to say just IC3D spools, because I think it's going to be pretty limiting. So we're going to try that.
Yeah.
We're going to try that, and we're going to see how it goes.
So is it any size spool, or like the 2.5 kilogram and the mega spools fair game too?
Any size IC3D spool in combination with the 1 kg inland spools. So that's where we're starting out with.
Okay.
And then on the 24th, we're going to basically have an open house for anybody who wants to kind of come by, drop off spools, and see the shop and take a tour. So we used to do a lot more tours pre-COVID. We used to have a lot of gatherings pre-COVID, and I think we're kind of itchy to be able to get back into that. But we want to get more and more people to be able to come through and take a tour. So,
okay, you guys want to take a road trip to Columbus on Saturday?
we'll be here.
It's
probably
tempting.
drink.
We'll be here.
I think it's like, I think you guys are like 7 hours from us. It's a bit of a trip.
I don't know anything going on.
Depends on everyone's got their different limit for driving. So
that's not bad. That's not the edge of my limit's like 11 hours. That's in the driver fly. I don't know.
Yeah, that's fair.
If you were to come to IC3D, we have an open shop, and you can always come back and check out and see what we're doing, see the manufacturing lines, see the printers, see what goes on. So that's the great thing about coming to visit in person.
Heck yeah.
Nice.
So, with your recycled PETG, tell us more about that. How's that? Like, what's the difference between recycled and like the normal PETG, like print wise and everything? Like, give us the rundown.
So print wise, it's a little bit more like PLA. The temperature resistance is lower. It's a little bit weaker. It prints colder, but it doesn't seem to warp as much. Not that PETG warps as much. It's just kind of like a little bit lesser PLA, I would say. Really good for making general anything. If you don't have any, hard requirements, if you just want to kind of print, like we're going to probably do a lot of our Toys for Tots out of recycled PETG. I have a chair sitting next to me that we made out of recycled PETG. I have a lot of the stuff I did in my van, a lot of the shelving things I did out of RPETG. So it's, something that is really easy to use. And for me, it's going to be a lot lower cost. Internally, it's lower cost for us, but we're also pricing it a lot lower than our normal material. So that's something I'm pretty excited about. I think as a U.S. manufacturer, it's difficult to make a lower cost material. And, even we're still sitting at like 25 a kg, but if you get into the mega spools, you're at like 150 for a 10 kg. And then I would like to get the black a little bit cheaper. We haven't changed the pricing on the black. Luke and I are still working on that. Some of the recycled PETG, some of what we're doing with the recycled PETG actually kind of came from some of our customers. We have one big customer who said, I want the prototypes that you guys make for us I want to be able to ship them back to you, and I want you to be able to grind them up and reuse them. In our world with thermoplastic, that's not crazy as long as things are kept fairly clean. And this customer,
Mm-hmm.
I would say we would probably do 50, 60 pounds a month of material or so. So it's not like a lot, but, you know, maybe compared to what, you know, kind of someone in their basement just playing around, that might seem like a lot of material. So, you know, over time they might 300-400 pounds, something like that. They'd ship back. We actually bought a decent sized grinder. And so we actually grind that material into a regrind. And we can mix that regrind back into this recycled PETG. Up to, I think Luke said he did up to 30%. I don't know if we tried to go higher or not.
We have not tried to go higher, but I'm certain.
Yeah, we haven't tried to go higher. So depending on how much recycled PETG we produce versus how much regrind we end up with, we have to figure out where that ratio is going to be. So I think my dream is that we'll be able to use black recycled regrind to actually color the new material black, which eliminates some of our cost, which would make the black even cheaper. So I'm hoping that we can make that black product cheaper. And even for locals, I want to do a discount for local pickup, because we do price things with free shipping at some point. So I would like to be able to do, if you're local and you can come and pick it up, there will be a further price reduction on the material. And I think that's going to also push towards future spool returns also as well. So, you know, I don't know how we're going to do that yet. I mean, we want to avoid a annoying system where someone returns a spool and they get a coupon, or, you know, we want to avoid a system where it takes a lot of manpower and effort to run, and do something simpler. I don't think we're there yet, but I think we're experimenting to figure that out. So I think building this local system is going to be key there.
That's really cool. So you said that when you're printing with it, it runs cooler and has lower temperature resistance. Is that a factor of like polymer degradation from being run through the extruder multiple times, or is that some sort of modifier you're adding to it, or what's with that?
Yeah, Luke, if you feel like you can answer this better than me, then definitely answer it. But I would say that recycled PETG is not, it's not our normal PETG that we've already heat cycled a bunch. It's a post-industrial waste that we purchase as post-industrial waste. So it's already considered, I don't want to say it's considered scrap, but it's you know, it's not meeting whatever spec they want. Yeah, so
it would go to the dumpster otherwise. So we're just keeping it from going to the dumpster, basically. But the polymer specs on that material are much wider than the polymer spec that we would use for our normal PETG. So you see a lot more variation in the material, and the quality of the material. And so that's why we're actually still kind of ironing out what the black PETG will look like. We have to play around with what percentage of regrind can we use, and does that percentage of regrind need to change based on the raw material that comes in? Because there's variability in the raw material, there's variability in the regrind, and we want to make sure that the output material that we're shipping out is extremely stable, right, and has no variability. So how do you do that, right? So you kind of have to balance the inputs into the extruder to get a stable output product.
Okay.
Yeah. And so that recycled PETG, it just has a wider spec on it as far as mechanical properties go. And from what we've seen, all the material that we've received, it has less thermal stability, and we have to extrude it at lower temperatures.
Interesting. Okay. Yeah, the stuff that I've printed, that very much holds true, but it prints really well. That's interesting. I went and toured it is a company that makes drywall products, and they make everything, or as much as they can, out of recycled PVC. So they make like corner beads and all that stuff, and they have a whole process ahead of time to remove all of the PETG that potentially comes in. They like run it through with a UV light, and the PETG glows versus the PVC. So it was really interesting seeing all of that, and now hearing this, like, huh.
So the PETG acts as a contaminant in their PVC product, so they want to remove that. It probably has similar melt properties, and it would destroy their process. We run into a similar issue with recycling PLA. So PLA, scrap recyclers won't take PLA because it acts as a contaminant for things like HDPE. So they don't want it.
Interesting.
They don't want to see it. They don't want it in their facility. And so it's really hard to recycle PLA in that way.
Huh.
That's fascinating.
It really is. I also saw recently a video on how the recycled plastic industry is a sham, and like almost no plastic actually gets recycled, and all of the symbols are just resin codes and not recycling codes.
Well, that's sad.
And that broke my heart.
Yeah, we want to change that. And, you know, that's something that I'm very passionate about. And I don't want to see PLA going into the dump. I don't want to see us have to burn coal or, you know, whatever source of energy we have our electricity coming from to heat a giant incinerator to like turn PLA back to biodegradable resin. Like, let's just make it back into filament, you know?
Yeah.
Well, so that's something that we're able to do with this grinder. And that's something that we're able to do and achieve with this recycled PETG product.
That's awesome. Now I'm going to buy more.
Well, down the road, we will do more recycled things.
Yeah.
This is just the beginning. We're trying to figure it out. What does it look like? How can we make it economical to the customer? One thing that Matt didn't mention that he is very passionate about is he prints. And he prints a lot of stuff for his van. And he is a consumer of, you know, consumables for 3D printing. And he wants to see that value passed on to IC3D customers. So he's constantly working to figure out, how can I make more value for IC3D customers? And that is something that we believe we are really achieving with this recycled PETG material.
Oh, that's awesome.
It's interesting because I think we do a lot applications wise for large businesses. We solve a lot of problems. We do a lot of like, oh, what temperature can do this and what strength and how can we design this? But the material that people are like, oh, what's your favorite material? It's like, well, I've used like hundreds of pounds of recycled PETG personally for myself, but I can't say that about any other material. It's my favorite one. It's just the raw material cost is affordable, so affordable compared to what I can do with it. Like, and I know that at least I'm like kind of giving a second life to something. And then I think on top of that now, the knowledge that like when we're done with it, I can just like, if I'm ever done with it, I guess, you know, we can just like grind it up and use it again. This is pretty cool. And yeah, it is pretty neat. And I'll say that's another kind of possibility going along with this kind of local spool return is ultimately like a future of like returning scrap or recycling scrap. You know, there's a lot of problems with that. It's not like we can just do it. But specifically like with this kind of big customer that we're trialing with, trialing this, you know, that is something legitimate. Like these parts that we're printing are being printed with the intention from the very beginning that they're actually going to get recycled. Like we know we're going to get them back in less than 12 months and they're going to get recycled. So they know that, we know that. And it's not like we're putting a stamp on it saying, well, you can recycle this if you want, if you can find a way, or if someone will take it. It's just purely like, these are have a limited life. They're going out, they're coming back, and we're done. It's not a perfect system, but it's a good trial. And right now we're calling it the circular polymer system because we want to actually advertise this and do more of it. Nice. How many other customers have that same intention? I'll give it, I'll give a hats off to them. They're kind of the first customer that ever came to me and were like, hey, as long as the price is about the same, like we want this, we want this to be recycled. And we're placing a higher value on that than just what's the cheapest. So if the price is the same, or even if it's maybe a teeny bit more, we'll do this because we know it's getting recycled. And I was like, whoa, no one's ever said that. No business says that. So that's pretty interesting. And so, you're like, this is, internally, that's what we want to hear. And I think that's something we want to keep pushing for. So, what printing service can we do where we can say, hey, by the way, when you're done with it, just give it back to us. Just cut it up.
That's really cool.
Yeah. So again, locally, it makes
really
a
interesting model.
It's easy local. Far away is hard.
Mm-hmm.
So the system will be difficult, and it's going to be something that takes a little bit of time to tease out. So
I had two more comments on the actual printing with RPETG. I actually think Matt's better qualified to talk about it, but I just wanted to mention it. So with large format printing, the RPETG is pretty cool because it works well as a high flow material. I'll let Matt talk about that. And then the other aspect is, so our fulfillment manager, Ryan, he has a home built 3D printer, and he's got it set up really well with some good fans and good cooling. And he's actually done some really high detail prints with RPETG. So it takes more tuning and a little bit more know-how, but you can actually do like high detail cosmetic printing with RPETG successfully. And then at the same time, you can do large format 3D prints as well. And Matt's done a lot of large format 3D prints.
Yeah, actually,
big nozzles.
I don't know if you guys saw this when I brought it in, but I actually am sitting on a 3D printed chair. We do a lot of printing with we have a bunch of IC3D supers, and we drill the nozzles out to 2 millimeter. And so we do a lot of 2 millimeter by 1 millimeter layer height. And we have a 2.5, but it gets a little wonky at 2.5. You're just going from 2.8 to 2.5. And we had a little bit of issues where the center of the strand is still kind of not fully melted. It's pretty weird. So, yeah, we're trialing some of the newer slice hot ends because we're pretty happy with the slice hot ends. So I'll say I'm excited to see where that one goes. But for now, we're using mostly the IC3D supers, and I'll get up and show you guys here this chair. So here's this is the chair.
Oh, that's amazing!
30 pounds
wow.
of ABS right here. So, and then I'll pull this webcam down. You can actually see here the layers. I don't know if you guys can see that or if there's not enough light. But
we can.
Yeah, just the kind of thickness of the bead.
Yeah.
So, and I'll say that ring right there, that was just, we were using scrap ABS and there's a little bit of black that got in there. So that ring, but this is all done in one piece. You can see another ring on the bottom. It's all one piece.
That's
there.
awesome.
So, and then I have this is an RPETG, there's a black one in the corner there.
Okay.
It's funny. The ABS is actually so much lighter than the RPETG. It's just the property of the plastic, but until I picked them up, I never really noticed. So,
what kind of print speeds can you get out of RPETG when you're doing a big nozzle like that?
I think we still print pretty slow. I want to say we're still 30 millimeters a second. We're not super fast.
That makes sense because you have to heat it up.
Yep. Yeah. So we probably could run faster and run a lower flow, a little lower, but I'll say it's funny. The big nozzles are actually kind of less prone to issues. I mean, you definitely don't want to be doing a ton of islands, a ton of Z hopping around and jumping around. But if you can do one nice big continuous, we'll do the, not the rectangular infill. We'll do more infills that have just kind of they're not drooping on each other like full infills. You know what I'm saying?
Right. Like grid or zeroid.
Yeah. So just anything where you're not going to get a lot of drooping because that can cause some issues. But it prints really well, actually. There's not a lot of problems, which is pretty cool.
How have you combated Z-seam? In the past, when I've done big thick layers, when you get the lift at your seam, you always end up with like a gap before the filament extrudes far enough to contact. And yeah.
We have it dialed pretty well, but there's still a pretty big Z seam, and it's still there.
Yeah.
So I'd have to talk to Sean to see what he's doing, but it's gotten better. But I think the earlier prints we had like gaps, like big gaps,
gaps.
Figure it out, but it I think on the furniture and things, it just doesn't seem to be too big of an issue. It's just, It's kind of always a spot where it's just kind of there, or he might randomize it and maybe it doesn't look too bad randomized. A little bit.
Yeah, a few years ago, I built an 8-foot tall printer and it was a precursor to a super volcano. Mm-hmm. It was one of the things that convinced E3D that they really should build a super volcano.
Was it 2 volcanoes stacked?
No, I actually machined the heater block. It had 2 40-watt heater cartridges in it from the side, and then machined a nozzle to go in it. But it was a 2mm nozzle, and we printed a 7.5 foot tall rocket with.
Was that at Murph?
It was at Murph.
Mm-hmm. Yeah, I saw that machine.
Yeah, it was a giant piece of crap, but I built it in 2 weeks. So
and it worked.
Yeah, that's what Murph is for, though.
It is. That was exactly what it was for. It printed that rocket, and that was the only thing it ever printed. I printed a few things with the hot end on other printers, but like that rocket had like 5 kilograms of filament in it. It was too expensive to like just constantly make stuff with.
Yeah.
But we ran into that same thing where the core wasn't melted with the first try of the rocket. And we ended up having to run PLA through that thing at like 290 at 30 millimeters a second to get it to fully melt.
Yep.
Sounds about right.
Yep. Yeah. I think that's the interesting thing that took us a while to learn. It was like, you don't really know what the temperature at the nozzle is. You just know what the temperature of the block is. And so, your basic heat transfer equations kind of tell you that if you want to transfer more heat, you got to raise the delta T. So you got to raise the temperature. So, it's funny you're at 290C on PLA, but it's not actually at 290C. It's like the nozzle's really at whatever you want it to be at 210 or something like that. Just don't let it sit very long. Don't let it stop and wait.
Yeah.
It's going to be a problem.
Yeah.
Yeah, we did that before the supers with the two volcanoes. We stacked them on top of each other, and E3D told us about that, and we tried it. And we were doing jobs better because of that. We were dropping time off of print jobs, and we were doing it. It's a big deal.
I sent Sanjay pictures of this hot end as I was making it, and he was like, "Dude, you could have just stacked 2 volcanoes. It would have been fine." And I was like, "That's a thing? I put all this effort in. I could have just did that."
He told us about that, and we were like, "Huh, that's a good idea." And we did it, and we made a couple, and we just kept doing it. And the supers came out, and we bought a bunch. I think we bought 10 or something. So,
So how far can you go with that? How many volcanoes can you stack?
It's like infinite. You just keep putting heat breaks in it as couplers.
Yeah.
And
eventually that little E3D heat break is like hanging on for dear life. We broken so many heat breaks that we just started machining our own without the cutout. So we just were taking M6 stock and machining them because that was the only way we could keep them from bending. It was like, especially with the high flow stuff, if you get one thing wrong and that nozzle starts bumping on something, it's bent. It's done.
Yeah. So you mentioned that you guys are getting ready to make your own printer. I really want to see that personally. You can show it off on the podcast if you want. I want to see it though. Yeah. And then at Verf or Murph, one of the events that was virtual, you guys were showing off these like massive printers. Can you show us those?
Yeah, absolutely.
Are those where you are?
Yeah, that's where I am. 100%. Yeah. So I'll give you guys some background really quick. So we've had a printing service for 4 years or so, maybe, about 4 years, I think. And we decided we wanted to start printing larger format. It was kind of a personal thing because that's kind of fun. But also, this would be a good thing to be good at. Is something that we wanted to do. And so as a small business, being pretty scrappy, there weren't that many people building large format machines. The cost was fairly high. We started making our own because, you're a bunch of engineers who are 3D printing and you built printers in the past and you're just kind of a little bit naive. And you're like, oh yeah, we'll just do it. So we've had a couple generations. I'd say we were very proud of our second generation, which is probably what you saw was big. After using it a lot, we thought, well, here are the things we need to change. And the third gen is the machine that we're going to be selling. So we call that the Virago machine. It's the Virago 700, 600 millimeter by 700 millimeter by 785. So that's about 2 feet by 2.5 feet by a little over 2.5 feet. So almost 3 feet in Z. So that's a medium-sized machine. We call it a medium-sized machine. The bigger machines, the Gen 2 machines, they're 4 foot by 4 foot by 3.5. So we have 4 of those machines, as well as our Gen 1 machine, which is about 3.5 cubed. So they're decently big. They're all lead screw driven. They've got aluminum extrusion frames. You'll see with the new machine, it's all steel frame, and it's all ball screw driven, and it's all THK brand ball screw and carriage rail. So it's the nicest machine we've ever built. We put all the monies into it. As far as we didn't, spare too much. So I think you'll see it, but yeah, the steel frame itself weighs about 750 pounds, maybe 800 pounds. It's all welded steel, quarter wall tubes, 1/2-inch plate on top. It's nice. I wanted to tell you guys that. I want to tell you guys that now, just so when we go out and see it, I don't have to, spend too much time out there explaining it. So I'll go show you guys that. If you don't mind, we'll go take a quick walk.
Matt, you should tell them about the IC3D code name for the printer. Each printer gets its own name.
Let's see. Yeah. Big Rhonda. Here's our space themed room here. Got a little
that's fun.
BMX bike frame action. Little stormtrooper head, little wheel. So
yeah, little prints.
Yeah, there's a crate here for a trade show. So there's another chair there. There's the power armor.
That's Yasu's power
armor. Nice.
Yasu's power armor. Okay, so high bay back here. You guys will see Taz, little Pharma Taz's here. It's Sunday night, so a lot of stuff's maybe stopped running. So these are our big printers here. So
those are fun.
Yeah.
So are those all stepper driven?
These are all steppers.
Okay.
So you see lead screws. Got a little bit of insulation in them.
Do you have heated enclosures on those, or are they just heated by their bed?
They are just passively heated, yeah.
Okay.
Heated by the bed.
Heated. I mean, it's a 4 kilowatt bed. So
yeah, I was gonna say, the bed is kind of an enclosure heater at that point when it's 4 foot by 4 foot, but
it gets warm in there.
So,
I bet.
Try to see the thing. It's actually pretty tall. I mean, you can't really see me next to it. It's about a little taller than me. It's about 6.5 feet tall.
That is much bigger than I thought it was.
But yeah, I mean, if we go through here, you'll see the welded steel frame here. There.
I wish we could. I almost want you to be like Matt, pull off a side panel. There's just a lot of thought that's gone into this printer.
I do want to pull off a side panel. They're just very heavy, And
they are. Yeah, it's almost impossible to do with you holding your webcam and laptop, but it really is cool.
You'll see these ball screws here, ball screws up top. You'll see it's IDEX.
Oh, wow. I didn't realize it was IDEX.
Yeah, it's IDEX.
So you run dual ball screws on the gantry then?
Yep. Dual ball screws. So it's going to be, I can't see it because it's so far back there, but there's encoders on those motors, so they're actually closed loop motors.
Nice.
You should probably tell them about what our hot end is too. And then we've got separate filament storage on the printer underneath. Filament routing goes up through the back of the machine.
Ooh.
Yeah, the hot ends right now, I want to show more of a close-up. We're running Slice Magnum Pluses. We're going to be trying, Slice the Magnums. And we're going to be trying, I think it's the Plus, the step up from that's got the dual heaters.
Okay.
And that'll be kind of the next thing that we trial. Those guys have said that there's pretty good results. I'm a little disoriented here. So we're definitely excited to test them, but we've had really good luck with the Magnum so far. And we're running Dyes extruders. The Dyes extruders, we've been pretty happy with them. We haven't got to try the LGX, the Bondtech LGXs yet. So that's going to be next. I'm pretty excited about the LGX. Everyone in the shop really wants to try the LGX. I'll show you
those look great.
Actually, which head's running here?
I think the black head's running, isn't it?
It's the red head running here. So we'll see if it should trigger here soon. Yeah, there.
So this machine has the filament feeders running on it.
So you've got dual 10 kg filament feeders right there underneath.
It's like it's belt driven from a 24 volt DC motor. It's got a relay on an end stop. So whenever the filament hits the end stop, it dulls out a little bit of filament.
That's so cool.
So you don't overspool. It can't spin on its own. So you won't get any freewheeling on your mega spool.
Dope.
That's awesome.
I like that a lot.
Is the filament storage like heated or dried or anything?
It is not dried at the moment. So we're probably just going to keep some Ava dries down there for now. It's definitely been a question we've been asked. So it's in the books as far as something that we might be working on improvements in the future.
Okay.
So.
Right now, just the bed heat alone is enough to keep the filament pretty dry. That chamber is going to stay fairly low humidity. But yes, in the future, we would have the option to do something like a dried filament storage area.
And it looks like a duet control.
Yep.
Is that a duet 2 or a 3 or? Nice.
Yep, it's a 3.
So all the panels on the entire machine can come off. So it's pretty easy to get to your print. It's pretty easy to work on. That entire side panel there with the IC3D logo, that is removable in about 2 or 3 seconds. So you really can break this down to the bare bones frame quickly if you need to work on a print to clean off the bed.
So you said that those motors are encoded. What motors are you using? Because you can't run an external driver off of Duet 3, can you?
So we are just working with Duet. They're working on a board. So they're working on the ability. So I will say this. I didn't say they're not currently functioning. So we're kind of waiting. Okay. We're kind of waiting for that functionality to come. But we've been discussing with Duet, and the functionality is on its way. So it has not happened yet. And
awesome.
The timeline is unfortunately
that sounds
not. We're not really sure kind of when it's going to happen. But we've been very happy with the machine running without the closed loop. So if it becomes an issue, then
we've all been running. That's rad. And the Duet guys are great about those feature ads, and like when you come to them with a really good engineering idea, they're like, yeah. And then they get just as excited about it as you are. So
absolutely. Yeah, our electronics guru has been working with them pretty closely. Matt Moore has been working with them very closely, so it's been good.
Nice.
I probably should have gone back to show you guys the extruders, huh? I didn't think about it.
Yeah, you should show them the giant grinder.
Yeah.
Also, yeah. Show you guys the grinder. All right.
Hey, we got
the
time.
grinder, the extruders.
All right. Let's go back.
All of our resin dryers. There's a lot that goes into making filament. But I also wanted to mention that if you Google IC3D filament GitHub, you'll actually be able to see our open source GitHub repository, and you'll be able to get an idea of how to make filament from that. Not much has changed in making filament, since the invention of injection molding machines and extruder machines, single screw extruders. And you can see our line 2 right there. Matt's walking by the water bath systems right there. Down on the ground in front of him is a giant water heater. There's the head of the machine, the die, and then show him the nozzle. That's the water heater. Show him the nozzle and the die. So this is actually the nozzle on the. We've got a 5 millimeter nozzle to make 3 millimeter filament. So you're drawing down the hot plastic as it comes out, drawing it down through a water bath. You've got a set of conveyor belts that are pulling it at a constant speed. The machine's running at a constant speed, and the difference of those two machines maintains the diameter of the filament. We recently added another piece of technology called a blender. It's that black and red thing sitting there on the top of the machine. So that's actually got 4 independent hoppers, and you can run different materials and different color additives in each hopper so that you can blend things. So this is called a blender. It uses a gravimetric weigh scale to actually measure out small amounts of material, mixes them up homogeneously, and then drops it into the extruder throat. And so that's how we're making the Recycled PETG.
Wow. Awesome.
So this is all new technology that we've recently added since we started making Recycled PETG.
Oh, that's crazy.
And then over where Matt's at now is all of our dryers. So that's a Novatech dryer there. That holds about 250 pounds of resin. We've got PETG loaded up in there right now, I think. The other 2 dryers across the way, we've got our experimental high temperature PETG, and then we've got, I believe, ABS natural in the little blue dryer there. So all the materials have to be dried for at least 8+ hours before we can run any of them. And everything needs to be kept basically out of the atmospheric air. That's all of our filament storage over there. We've got about, what is that? Like 3 or 4 tons of material.
Yeah.
1,600 pounds times 6.
Yeah.
So we've got a lot of material
on the low side.
Yeah, we are actually on the low side. We are understocked right now. And then this is our grinder.
Pretty big. I don't have any scale. Maybe you can see the grinder compared to the forklifts.
But basically, we can load full-size, large format prints into the front of that grinder, and it comes out as pelletized plastic, and then that goes back into the machine. It comes out the side of that big funnel-looking thing that's tucked away right now.
Okay.
But,
is there regrind if I open these?
Yes, there's regrind in there. There should be black regrind in that one right there, Matt. That should be black PETG regrind. That
I remember how to open these.
Customer that we just yank on that.
Hold on. Let's put this down for a minute.
So the customer that's asked us to make, recycle their prints, their prototypes, that bin is full of their prints.
Pulling the wrong way. I'm sure you know what you're doing. Yeah.
Maybe pull a handful out of there, Matt, so you can kind of see what it looks like.
There we go. So
it's kind of powdery. It's a little different than what our normal raw material looks like, but that's actually looks like it's mostly support material right there. You see the layers. Oh, wow. See the layers of the 3D print and the little small pieces. So that looks like it's mostly support material.
Does the powderiness and not necessarily granular consistency matter when you're running it through?
Absolutely. And that limits the maximum amount of regrind that you can actually run into the extruder. And so the weigh scale blender is great because the way that the solenoids. It's got air actuated solenoids. And so those air actuated solenoids, one of them is designed specifically for adding regrind. So it helps deal with the powders a bit more. But if you have too many powders in your extruder, they stick to the throat, which is the area of the machine where there's unmelted plastic. It's called the solid bed area. And if powders build up in the solid bed area and become softened, then you'll jam the extruder and you will lose the strand and you have to pull the whole machine apart. It's kind of a nightmare.
Yeah. How often does that
it's
happen?
Like 8 hours later type of job. You know what I mean?
See this product here on the shelf.
That's all PETG.
There's some mega spools of our colors. Yep. Okay.
PETG, and then we've got PLA. We've got one bay of PETG there. We're a little low on stock on the 175, it looks like. Then we've got all of our PLA product. We got 2 bays of PLA and 2 bays of ABS. So we are fully stocked. And we've got an entire greenhouse behind Matt that's also full of filament. We've got 2 greenhouses. We've got one that stores print shops filament, and then we've got another one that stores customer filament. So
okay, are those greenhouses for like climate control and dryness and everything?
Exactly. We've got dehumidifiers running in there, and then we've got sensors that are telling us the indoor and outdoor. Well, sorry, the shop humidity and then the greenhouse humidity, and we're trying to regulate that to under 20% at all times.
Nice. Anything else for our walk back? Anything else?
Show them the respoolers, maybe the fulfillment area.
Respools.
So the large mega spools obviously get broken down into smaller spools. And so we have our own in-house machines that we use to do that. So mega spool sits on that giant aluminum bar there to our left. And then the smaller spool gets loaded here onto this blue motor. And then there is a traverse mechanism that travels back and forth and is matched to the rate of rotation of the smaller spool. And then we actually count, we do it by rev counts. So we count the number of rotations to find out when the spool is full. And then the machine just shuts down automatically for the operator. We've recently added a bunch of upgrades. So like, as we just talked about, the mega spools, they're always over spooling and freewheeling. So we just added a disc brake off of a bike system. So we've got disc brakes on there now. They're actuated by solenoids. So when the spool finishes, it will actually close that disc brake and stop the spool so it doesn't make a tangle for the operator, so they can start the next spool a lot faster. So a lot of fun DIY projects around IC3D. We recently upgraded from using, Arduino Nanos and Arduino Megas to PLCs. There's a cheap Siemens PLC, like an entry-level PLC that we're now using to control those respoolers. And so our owner, Michael Cow, actually just got done upgrading us to those Siemens systems. And those are actually able to be accessed from our network, so we can upload new source code remotely. And
you guys didn't even cheap out on your PLCs and do an Automation Direct one.
I think that actually is an Automation Direct spec. It's Automation 24, maybe.
The Automation Direct has their own brand, and they're cheap.
Mm-hmm.
That's awesome.
We wanted to get Siemens. We wanted to get Siemens stuff. We need reliability at this point. We can't have those machines breaking down. So there's all of our spooled product on the left that's vacuum sealed, waiting to be boxed up. Matt, show them the vac sealers, I guess. We got 2 vac sealers. This is our staging area where we box the product up. There's our vac sealers. So this is, I don't know if you guys have met Ryan, but Ryan's active on our Twitter accounts, and he runs all the fulfillment. So this is Ryan's world.
Okay. I think I've met Ryan before.
Yeah, you probably have it. Maybe at Murph.
Yeah.
He was at the Murph table, the last live one.
We were there. He probably came and got beer from us.
Probably. He definitely has a good beer. So yeah, that's the shop, guys. I don't know if there's any questions. I kind of a very brief overview, but yeah.
Oh, this is
awesome.
Matt, show them the frames for the Virago. I think that's interesting. Sure. So that's what it looks like when it's got the body on it, but the frames are over here in the corner. So the empty frames look quite a bit smaller, but you can see how those panels pop off the sides so you can get to the bed and everything.
little
so
bit,
all the
little bit
electronics
messy,
are
but
down underneath.
you can see a little bit more. It's all milled aluminum blocks holding everything.
Do you guys do all the welding and machining in house?
No. Those are all local vendors.
Okay.
We have a great local vendor out of Circleville, Ohio, that makes the frames, and they are extremely professional and timely. I don't think I could ever. I don't think we could compete with the quality that they turn out for the price that
frames. The frames are pretty wild.
They look impressive. Really well built.
They are very well done. So you can see a little bit more of the beds here. So
there's some isolation, heat isolation between the bed and the aluminum frame that's actually attached to the lead screws there.
Okay.
And it's magnetic build plate, so that the bed is removable.
Yeah,
that is a huge build
custom
plate.
Yeah, it's a custom build plate.
Yeah, I think we're going to ultimately be moving to embedded hard magnets, but I think this was like a really fast way to kind of get going.
What are you guys liking for bed materials for the massive printers?
Well, I'll say the Virago's running PEX right now from Wham Bam. We are trialing the powder-coated PEI. So we do use the powder-coated PEI on our Tazas right now. As far as the big machines, the beds are so big that we don't have removable plates. So we are using bed weld.
Okay.
We're using layer near.
Nice.
So we've tried a few other things. The layer nears seems to be the most universal. So
okay.
That I hate using bed weld on a giant machine, but for now, unless we switch to vacuum beds and we mill big beds, it's the simplest method to go, and it's been working fairly well, surprisingly.
Yeah.
But it's really difficult to say, start this huge, awesome printer, and here's your little glue stick. It's not a glue stick, but you know what I mean.
Like, basically, though.
Yeah.
It works well.
Oh,
what questions do you guys have? I mean, we just showed you a lot. I'm kind of curious where your minds are at, or like,
So on your respoolers, are your traverses tied to, like the amount of filament that's on the spool? Because like that diameter changes, right?
Yes, the diameter of the spool grows as you turn more revolutions, right?
Right.
Absolutely. So then the traverse is mechanically connected to the motor that's turning the smaller spool, and it turns at a predetermined rate that you can adjust on the fly. We normally would not adjust it. It's the traverse rate is actually more tied to the diameter of the filament that you're running, right? So if you're running like a 175 filament, it doesn't fill up the row as quickly as the 3 millimeter filament would. So you have to turn up the traverse rate for a 3 millimeter spool.
Is that a calculated rate, or is it like that looks pretty good? Like potentially,
it's eyeballed. Kind of thing? It's eyeballed for right now. It's manually done by the operators, and it's manually tuned over the course. Let's say you're doing a mega spool, right? And you've got to do 10 1 kg units off of that. It's kind of a set it and forget it, but you're going to want to manually adjust it here and there. More so the end stops on the traverse than the actual traverse speed. Now we're working on a generation 2 respooler where that is actually done with a stepper motor. So we're basically taking 3D printer technology and sticking it on our respoolers, right? So we're going to have end stops, stepper motor with the lead screw. The traverse is controlled by, a PLC that's connected to a load cell. That load cell is measuring the tension on the strand and maintaining a specific amount of tension on the strand. Those sort of things you need to do to achieve like a perfect wrap every time, right? So we're not able to go out and purchase a commercial respooling machine that's robotically controlled. We can't afford a $100,000 respooling machine, but we can build something that does the same thing for a few $1,000s. And the cool part is we have enough in-house experience between the various guys here. We all tag team a project like that, we can make it happen. So
yeah, I built effectively the exact same machine for the textiles industry in a previous job. Like,
oh, neat.
Stepper driven traverse. The traverse speed was kind of governed by where we were in the wrap. It was.
Yep, absolutely. Yeah, we'll be able to do those sorts of things on our upgraded machine. Right now, we're kind of, it's a bare bones operation in that sense.
Interesting.
That's really cool.
Yeah, that's neat.
I have a question. So I think this whole recycled PETG and the recycle spool program is a really kind of innovative program to try and pioneer. I haven't seen that much other innovation in the filament space besides like, was that the expanding PLA, whatever. Where do you see the filament space going in the future? Because it seems like we're kind of running out of innovations in the filament space, and all we're seeing is just kind of new colors and different blends. Like where do you see this filament space going? And do you see like any new filament makers coming out? Like is it that saturated now? Like is there no point in making new filaments, or like where do you see that going?
Great question.
Yeah, that's a good question. So I'll say with what we do, being vertically integrated, having a little bit of every single piece of the puzzle, we like to say that we like to solve problems or develop new applications. And so that the Virago printer specifically, I'll use as an example. When we sell that to a customer, we intend to be developing. We expect most customers to be printing one or two things only. Now, obviously, there's going to be a lot of people who just want to prototype and print lots of different things. But in general, you find big companies, they find, man, I've got this piece for my telescope. I do 30, 40 big telescopes a year, and I just need to make that one big piece. It's really hard to make any other way. Cool. That guy, he's probably only be printing that one piece, maybe two pieces. And so we expect that guy is going to be coming to us. We're going to say, we're going to dial the material in, we're going to dial the machine in, and we're going to give them the machine, say, hey, it prints the thing you wanted. So I think that you're going to see in the material world the same thing you see in, I don't want to say injection molding, but in resins and in thermoplastics in general. You're going to see things built for very specific applications. And I've even had filament, I've had bigger companies kind of pitch materials to us and say, hey, we got this new material. Here's what it is. You want to try it? And I'm like, cool. What do you do with it? And they're like, automotive, or so, they give me like a generic. I'm like, no, like this is a very specific thing you have. Like, what's your application? It sounds like there's a reason you made this. And sometimes the reason could be we are really good at we are X resin company. We're super specialized at this type of resin. We wanted to get into 3D printing. That could be a reason, but they might not say it. But the reality is that I think like our ABS is made by a company called Chime. Chime makes like 40 ABSs, like I don't know, 50 ABSs or something, So you think, well, in filament world, ABS is kind of ABS. There's different ABSs out there for sure, but no one's sitting there going, well, I like ABS M30 because I'm going to be, exposed to this much UV and no one's doing that kind of thing. So I just think as you get deeper and deeper, you're going to start seeing, I don't want to say UV PETG is a really basic example, but man, I like PETG, but I need to use it outside. All right, here's PETG with the UV additive. Cool. IC3D could release 5 PETGs. We could release a UV PETG, our regular PETG, a recycled PETG. We could put an impact modifier in our PETG because PETG is kind of brittle. Like, I think you're going to start. I mean, at least personally, that's what I need as an engineer. We're solving problems. And we just ran into that problem the other day. We had a guy who's printing all his parts out of PLA, and we go, all right, well, we'll print these out of PETG. It'll be a little bit better. He's like, cool, that makes sense. And the PETG was too brittle. and it's breaking when we put it in. And typically we'd make a design change, but the PLA works, or we're going with PLA, but we're like scratching our heads. We're like, I've never seen that before, So now I want to be able to go to my catalog and be like, I need a PETG, but I need to be less brittle. Well, I don't have that, So that's kind of the tricks. I think that's where we're going to be headed. And at least for IC3D in general, we're behind on releasing filaments, but we're I think ahead on kind of trialing different things. And there are a lot of resin manufacturers that you're seeing. The big resin manufacturers are coming out going, all right, well, we have like 1,000 polycarbonates. Like, here's 4 polycarbonates. So you're like, all right, well, that's a good start. That's cool. But I think the difficult thing there is also those guys are going to get discouraged really quickly, because this is kind of a long road of teaching people how to use those 4 different polycarbonates, and they're not going to make as much money as they're used to making for a long time. And you see that battle happening. You see Owens Corning was in, and then they pulled out, and I think DuPont was in, and their stuff was awesome. DuPont's gone. They're out. Maybe they'll get back in later.
Right.
But, so this is a really long-winded way of saying, we're just going to start growing into application-specific materials. So, yeah.
Nice.
That's what I think.
I want that impact-resistant PETG.
Yeah,
I get it.
Yeah, there's a lot of different props that I'm thinking of.
I'm glad you said that. We have a 70D TPU.
Yeah,
okay. And
sure.
it feels like hard parts, but you could hit it with a hammer. It's super high impact. But it is kind of expensive still. It's TPU. And it still kind of comes with TPU quirks, although you can run it really quick like PETG. But I would prefer a PETG with a little bit less brittleness. And it's something I've been desiring myself. So I think it's going to be something that we work on. And Luke's working on an SBIR with Army for making tooling. And that's a very specific material. We want a material. We're going to be using it for tooling for potting wires. So they're going to be the custom cables. They're going to pot these cables with 2-part mixture. The tools sit at like 190F for like 30 minutes or something. 180F for 30 minutes or something. And they want to be able to print them. Yeah, and they want to be able to print them on a basic printer. So, there you have a really specific application.
Yeah, they want to use like a commercial off the shelf, like a Taz.
Yeah.
Hey, the Army always has such reasonable requests, don't they?
It's really not crazy.
They've opened up a lot more recently.
Yeah, it's really not crazy. So
they're
I think
open to some other printers. I'm hearing about. I'm sorry, I'm thinking Maker Gear. Maker Gear came out with their high temp printer, right? What's that called? Something 1. Anyway, their high temp. The Ultra 1, yeah. So we recently heard that they're open to possibly purchasing a machine like that to run this tooling material. So that's new, and it's pretty cool. I think we're seeing some changes within, within the government, within the Army. They're definitely a lot more open to trying new things than I think people give them credit for. Let's just put it that way.
That hasn't been my experience on the project I am currently working on with them, but I'm glad that you have a team that's working with you.
Additive manufacturing group might be a bit different, a little bit more progressive.
This is concrete additive manufacturing. It's the same but different in a whole stupid world.
That's pretty cool. I have lots of questions, but
I wanted to kind of answer Aaron's question a little bit from my own perspective. I think Matt did a great job answering it. I'm just going to give a very blunt answer. I think more of a high level, straightforward answer. I think that yes, you're going to see application specific materials coming out. Is the market saturated? Not yet. Is it quickly becoming saturated? Yes. Who's competing in those spaces? I mean, bigger filament companies are churning out new materials all the time, right? Like if you want to go find an application specific material, you can. They're out there. You probably never even heard of them, right? There's a lot of materials out there. There's hundreds. I would say there's probably thousands of materials available now. There's at least multiple hundreds of materials available. And, you know, they're varying in cost, right? Like, are they achievable for a hobby type person? Are they achievable for somebody like myself printing at my house? Probably not. But then I think the other part of your question is the filament world going to change dramatically? Like, is there going to be anything that changes leaps and bounds wise? I don't really think so. Like, I don't see the raw material changing that much. I mean, it's like 3D printing, right? Like, people have been using ball screws and stepper motors for 30, 40, 50, 70 years. Like, you know, it's been, you know, this stuff's not new, right? Like, we're still CNC machines and 3-axis machines haven't changed in eons, and they're not going to change. Like, that technology doesn't change. So filament, I guess, you know, that's not going to change as far as we're going to have to feed plastic into the machine somehow. Now, is pellet printing going to change things? Yes, absolutely. Are you going to see a lot more people doing their own recycled materials? Are you going to see a lot more people playing around with mixing resins at the hobbyist level? Absolutely. I mean, when people get those, you know, when people get a hold of something like that, what's the first thing you're going to do with it? You're going to play with it, right? You're going to mess around, try some stuff out. And probably people in the industry that, you know, larger companies that are in the industry are going to learn from hobbyist type folks doing funny stuff, doing things that they didn't think of, experimental stuff. That's going to happen. But I think you'll see that, you know, anybody can make filament, but my biggest fear, I guess, or not necessarily a fear, but, you know, how do things normally go in any industry? It's diversified at first, and then somebody comes out as a front runner and it starts to monopolize, and then you start to see one brand take over, right? That is something I don't want to see happen in a 3D printing industry. And I think we're far off from that, which is great. And that's somewhat due to the love of open source that like 3D printer enthusiasts have, which is great. So I think that keeps things fresh. But I do think that eventually 3D printing will become a mainstream enough thing that large players with, you know, a lot of funds are going to get involved, and then you'll start to see things group up. You know, you'll start to see things group up a bit more. How far out are we from that? I have no idea. It could be 20 years. You know, I don't know.
It's already more consolidated than it was back in the Kickstarter craze of everybody was starting a desktop 3D printing company, whatever that was 5 years ago.
Oh man, that was crazy. So like, that's an interesting point though. Like, I keep waiting for, like, we've seen like the hype drop, like the hype shadow, right? Where, you know, it's become less about like everybody coming out with their own company, and now things are starting to stabilize. But I don't see this hobby dropping off anytime soon. Like Murph was a really good indicator of that. Like the last year of in-person Murph was just insane. And I think we were all kind of going into that Murph like, this year's kind of going to die. And then Friday was the biggest day we'd ever seen. And like everybody's usually half drunk setting their machines up on Friday. So it was really crazy. And then, you know, COVID happened and everybody was back like, oh, wait, 3D printing is a thing and they're important. So I'm curious what the next few years have to offer for us, especially with like patents expiring this year with SLS and the heated enclosure dying. I think we're in for a really interesting time.
I think it's fascinating because I think it was like the last like CES of 2020, there was like no printers like revealed there. And so people were saying, you know, 3D printing is officially dead.
Yeah.
It's like, you know, there's no new techie startups releasing a printer now. So now it's either a race to the bottom or a race in quality, you know, as far as, you know, demographics.
Yeah.
What do you guys think about SLA printing or SLS, or I don't know? Have you guys got into that at all? What's your thoughts on FFF versus SLA? I think that's
I mean, it all depends on the thing that you're trying to make. Like, it depends on, especially when it comes to a lot of the stuff that I make, a lot of that has to do with high detail. So there may be bigger parts of a complete project that I don't need as high a detail, or I can buff them out real quick, but there might be smaller parts where I need really high detail and I need it to look really good without a lot of cleanup. And so I'll absolutely use SLA for that. I've talked about it plenty. I got an Ellie Glue Mars as a joke, thinking that it was just not going to be shit, because like it was $300 on Amazon. I was like, this is going to be a piece of crap printer. It's not going to work. Like blah blah blah. That's one of my most dependable printers. Like, that is literally one of the printers that I can like hit go on and it's almost always going to work. There's only been a few times where it hasn't, and that was because I neglected cleaning it rather than it actually not working. And yeah, it's great. Whereas like FDM or FFF, like honestly, that's the one where I have the most issues. Granted, most all of my printers are custom in some way or another, and so I have made that harder for myself. But
custom, not in a good way.
Right. It's those very specific things where I'm like, yeah, you can go ahead and do that to my printer, it'll work. And then I just get stuck with a printer that I'm like, man, this is gonna work at some point. I just have to learn how to use this now. So yeah, it really depends on the application that you're going to be able to do it. I haven't been able to mess with SLS at all. But SLA, like if I'm doing any miniature work, if I'm doing any high detail cosplay parts or artwork or anything like that, it blows me away every time how good it is. And even with a real crappy program like Cheeto Box, like it works. Like you just throw it in there and it'll pop out a file that'll make it work. And I don't even have like a real good one. Like mine is still one of the original LCD screens. It's not one of the newer 4K or 2K models. So it's like, it's a decent screen, but it's not one of the better ones. But it still works. It's still a good printer. Yeah, like I can definitely see a good portion of the printing future leaning towards that because of high detail and low amount of post-processing that you have to do on that. Like the cleanup and everything is not going to get any better because it's just the nature of resin. But like
the resins are getting easier to deal with. But
they are. Like that was one thing that Joe warned me about when I got mine, was he was like, the smell's going to be terrible. You're just going to have to get used to it. I've never dealt with a smell. Like when I initially pull off the box, I'll get like a whiff, but normally I'm wearing a mask. And so it's like just a little bit, but it's like, it's continually advanced to where it's like, nah, not really. Like I just have it over a vent now, and that way it's venting out any toxic stuff that could be in the air. But yeah, like SLA is great, to be honest. Like,
yeah, I'm the exact opposite. I have a Prusa SL1, which is an awesome printer, but I joke that it's my only fans because the only thing I print on it is fan ducts for my FFF printers. Because I hate SLA.
Only fans. What a
you
joke.
need to label that. That's pretty fucking great.
Yeah, like, you know, I could print all kinds of awesome fan duct geometry with it, and they'll come out amazing and strong, and that's the other thing I do with it. But I really, really can't wait for SLS to get affordable and get awesome. You know, there's the one kit printer that you can do that's like $10,000. That's not a huge volume, but I'm really, really interested in that coming down to a point where it's in the couple $1,000 level and you can get really accessible with it. So,
is there any software that supports that? Or would it just be like super custom?
I really don't know. It's going to kind of be the same idea as an SLA, like a true SLA.
Yeah.
But I don't know. I haven't dug into it at all.
I'm just curious.
I bet we could talk Lightburn into doing it.
My take on SLA.
Yeah, just talking about FFF and SLA, SLS, like where's the market going? And I think that's just an interesting topic because each has its own niche, I guess. Will it always, will FFF always have a place? Will SLA always have a place? I don't know. Like, it's just an interesting.
Yeah. I mean, it's absolutely depends on what you're making. I would say that the thing I've been the most impressed by, and I haven't got to use one yet, but any of the powder stuff. So the SLS, MJF. I mean,
yes.
I'm definitely starting to look into, should we be using an SLS? Should we be using an HP machine instead of trying to print? Like we don't like to print small detail parts. If I have to do 100 tiny parts, the guys spend tons of time tuning them in. And then once they're tuned in, that kind of price for what it is just doesn't make any sense for us. So for us, it's always finding out what you do the best with the tools you have. So, we do the best with big prints. We do the best with a lot of kind of average geometry, medium size or small prints. But if I want to do, if I've got a customer that wants 500 to 1,000, something that's kind of intricate, needs to be functional, it's probably going to be done with powder, So that's really my favorite from what I've seen from the prints that we paid for and things that we've gotten back. We're definitely looking at making a lot of Virago parts out of SLS instead of aluminum or instead of FDM. Because it just looks so good.
Mm-hmm.
SLA, I think those are always going to have their place for something. But yeah, my experiences haven't been awesome. I haven't touched an SLA machine in forever. So that's like, don't listen to me. I don't know what I'm talking about. In the industrial world, the little bit that I've seen, there are a lot of material advancements, really cool, non-super fragile. It used to be super fragile. Everything was really fragile. And I don't think that's the case anymore. But I don't know I think it's like FDM where it's like pumping out a lot of parts in some instances can be difficult. I don't know. I've seen the little monoprice one, I think it's a monoprice one, that one of our guys was playing with.
Yeah, there used to be.
And he was like, I swear he was like pumping out parts pretty quick. I don't have that much experience with it. So again, I spend a lot of our time trying to find areas that what we do fits in, but the SLS and the MJF is hard to ignore for me. And Stratasys is supposed to come out with
for sure
competitor machine here soon. So we're going to see what that is.
Have you guys looked into like the granular machines? So not necessarily pellet feed, but like the granule feed. For like high flow and all of that.
How is that different from pellet printing? Maybe I'm not familiar.
They are Stratasys was doing this at one point where they were like a quarter the size of pellet. And it was on a machine that was kind of like the belt where it had like an Infinity Z and it was all hopper driven. That reminds me of another question that I had.
I feel like that's going to be similar to a pellet printer at the end of the day.
Yeah.
It's pretty much smaller. Yeah, would make it lighter, so that can maybe lead to higher print speeds. They're adding a very small amount of material at a time as well. Usually those are vacuum fed, right?
Yeah. At one point, there was discussion of a larger filament diameter standard for high output. Have you guys dug into that at all or messed with the hot ends that were?
We have made a filament that was a 6 millimeter spec. I think that was, was that a test material for a 3D platform, Matt? Is that right?
Yeah, it was. It was pretty difficult to make. I think we would be fine if we spent more time on it. I think at the time that the promise of it didn't seem to be super high. We spent some time on it, and then I want to say maybe we just got distracted with something else and just kind of moved on from it. But yeah,
that makes sense.
We did attempt to make it, and we did.
It has the potential to work. I think that when you work with filament diameters that large, it becomes cumbersome. And like if you work with brittle materials or high performance materials in that large of a diameter, it's going to be almost impossible to figure out filament routing for a head on a large format 3D printer unless the spool is on the head itself. Like it's not going to, at that point, you're going to want to go pellet. I think.
Yeah.
The couple of machines I saw it on, the spool was mounted way high directly over the filament platform, so like spool routing wasn't even a thing.
Right, it's just like way above it, so it can't get messed up. Yep.
Huh.
At some point, you're just feeding a rod.
But it looked like they were feeding Ethernet cable, is what it looked like, because it was like light blue.
I would have to imagine. I don't remember what it was like, Luke, but I have to imagine it was really stiff.
So stiff. And like, so, if that stuff isn't cooled in a perfectly straight line, then when it comes off the spool, it just wants to be a big coil, like a big spring. And then it gets caught on everything. It's just cumbersome. And then think about trying to use like a carbon material like that. It would be nearly impossible. Like, I don't think that at that point, I really think that you would want to switch to a granular or pellet fed machine if you want to hit high volume and high print speed and not have to deal with the headache of that huge diameter of filament. It's just too cumbersome, I think.
Interesting.
But it could definitely work.
I wonder if they sold any of those machines.
Yeah, I don't know. That's a good question. Yeah, I mean, they've got, if you look up online, they've got all their different heads up there, but I don't know which one's which. I will say they talked about it for a long time before we ever made any. And at the time when we made some, they had only made PLA. So it wasn't like they really had made a lot of progress, to my knowledge. I mean, this was maybe, Luke, a year and a half ago or something?
Yeah, it might have even been longer than that now. But I think around there, Matt, you're right.
They've been talking about it for like a couple years, I think, before we even were kind of in the picture at all with it. And I don't think they've gotten too far from what I know. So.
Yeah, because I saw it at the 2016 IMTS.
Okay, yeah. Yeah,
so that was a while ago.
It was a while ago. So it's interesting. I mean, at this point, you're going to see more pellet extruders be just off-the-shelf parts, at least in the industrial world. Maybe hobby world, there won't be. I don't know if there's any little guys that are well-known that are cheap, but in the industrial world, it was like these two people made their own. If you want to make a pellet printer, just make your own extruder.
Yeah.
Well, that's the only thing you can do. And now you can at least buy a few. There's a couple you can buy.
Huh.
5 to 10K, but you can buy them.
Yeah. Yeah. There's the one that just came out that was like $1,000. That was kind of enticing, but they showed it on like an Ender 3. And it was kind of like, why? But yeah. All right.
I mean,
do you guys have
pellets? Pellets really cheap. Pellets compared to filament, really cheap. So, from a personal standpoint, if I had to, I printed, several hundreds and hundreds of pounds of stuff for myself, but I'd rather just buy pellets.
I think that the one piece of information that's missing from that discussion about running pellets, though, is filament drying. You have to dry all those pellets. You're going to have a separate drying system that is then vac loaded and fed into your 3D printer. Those resins have to be extremely dry. You were talking parts per million pieces of, parts per million water content in each of those pellets to not have layer adhesion issues, to not have like zits on your prints and things like that. So one area that I think that 3D printing hobbyists haven't crossed yet is really like resin drying. That's not something that, hobbyist folks, they dry their filaments, but it's usually like baking it in an oven or throwing it in, a toaster oven for a little while. but that kind of drying is not going to cut it for a pelletized printer. So I think that that's one area that you will see boom. If pellet printing takes over, drying filament is going to become a serious thing, and there's going to be a new market for that type of stuff.
Is it like,
side note,
like a vacuum oven type thing, or is it like a hot air exchange?
Yeah, vacuum oven can work. The industry standard for drying plastic resins for the past 50 years has been desiccant dryers. It's a closed loop system. So you're forcing hot air into the resin, and then that air that is evacuated from the resin goes back into desiccant. So the moist hot air goes back into desiccant. It's cooled down a bit, and the desiccant sucks the moisture out, and then that same air is fed back into the resin in a continuous fashion. So that, and then that desiccant will actually become wet over a period of time, and so you'll have to renew the desiccant. And so there's different technologies for how to renew that desiccant, but the simplest way is to switch to a new bed of desiccant and then dry out the wet stuff while the dry stuff is in process and drying the resin, drying the plastic pellets. So that's kind of how it's done in the industry. But yes, there are other technologies out there. Vacuum, you can use vacuum, a combination of vacuum and heat and desiccant. You can even use microwaves to get rid of it. There's a lot of different technologies out there to get to dry filament and dry pellets.
Nice. All right. Well, we are way deep into this podcast. This is probably one of our longest episodes so far. Yeah. Do you guys have anything else?
Sorry about that.
Good discussion.
No, that's fascinating. Yeah.
I think, really we've covered, most of what we're trying to get out there is the recycled materials. We're trying to really kind of explain our involvement with, recycled materials and what we're trying to do and find ways to do more of it. So,
okay.
Any feedback, any feedback on our spool return system, really curious to see how it pans out. If you guys want to come visit us, come visit us. I mean, I would say even if you didn't have any spools to return on that day, you guys want to come visit us, let me know.
Okay.
So
heck yeah.
This is a work in progress. So we definitely want feedback.
And we love giving tours. So we hopefully with times changing a little bit, hopefully we'll be able to give more.
We like it when people come to visit us. We want to meet folks, show them what we're doing, talk, share ideas, of course.
Oh, that's great. That's a really good attitude to have. Awesome. Okay. Well, with that, I'm going to go ahead and say everybody should keep making stuff.
And I'm going to say this is the end of the podcast.
All right.
Thank you
Thanks, guys, for coming on.
Thanks for having us. This was awesome.
This has been awesome.
Yeah, I love doing these. So, yeah, if you guys have any questions, just, I don't know, anything in general that, you're just kind of thinking about later, just shoot me an email. Ask me anything.
Will do, for sure.
Awesome.
Especially
say hi to Ryan on the Twitterverse.
Yeah, say hi to Ryan.
See what he's thinking. He's got a lot of interesting input on all of this stuff as well.
But yeah, I appreciate you guys having us on. This is awesome. So we love doing tours. I really need to work on walking around with the camera a little bit better. I was like,
oh, that's rad. Well, maybe in the near future, we always have talked about doing a maker tour where we go visit places like you guys and do an interview and do a walk around to the shop and make a full YouTube video out of that. And right around the time we were going to start that, COVID. So, this year we're hoping to maybe do that. And you guys aren't that far away, so maybe that could be on the roster.
Yeah, let us know.
We would like that.
Awesome.
Did you stop the recording?
No, I did not stop the recording. We're going. Did you stop the recording?
I can't.
Haha! All right. This is the end of the podcast for real, guys. We're going to try not to Midwest goodbye this any longer.
We're professionals.
Sign something like that.
All right. Thanks everybody for being on. I'm going to click stop.